This is my first live stream. I know to do some stuff to create my labs, and I was tinkering around my labs, and I thought I could show you guys how to do this. I'm going to show you how to set up GNS3 and the packet tracer on a remote server. Going to use two servers. I'm going to set up the GNS3 on a Ubuntu server and the packet tracer on a Windows server. Why I'm using packet tracer and GNS3? Because both are the most popular and they are both free. And I'm going to set up those remote servers in Amazon Web Services, AWS, mainly because they have the free tier. This can also be applied to Google Cloud Provider and Azure and Linode. I'm going to show you with the AWS also because it's the most popular. PacketTracer is a network simulator, which means that it models some aspects of the systems that we're going to use. What we're going to try to do with those tools is to set up our own network architecture and to try out some things. That's what the training is. And I'm going to show you how to install that. PacketTracer have some limitations with the equipment features inside that. It is free, it is easier to install, it is easier to use, but some commands might not work how you expect and some commands doesn't work. That's the downside of it. GNS3, it is a network emulator. It enables us to use the actual system. The good side of GNS3 is that you can use and run real iOS images or real network devices images using that in virtual machines, but the problem of that is first you have to have access to those images. With Cisco is not free. You have to have a legal contract with Cisco to download those iOS images, but there are other images that can use. You can set up more complex scenarios that require more CPU usage because you're basically gonna have a bunch of routers and switches as you would on a production environment. Most likely you're not going to be able to support that in a desktop. You're gonna need a server for that. That's why I'm going to set up a GNS3 on a server. First, you need registered in the Net Academy with Cisco. Okay, resources, download PacketTracer. There's the information what you need to. Should I install PacketTracer on my desktop? Yes, it's probably gonna work. You gotta check the the requirements here first. Why I'm doing this on a remote server? Because maybe you don't want to install something on your machine or you don't have the access to, or you don't want to mess up your home setup, you're not sure how to do it. Setting up this on a remote server is just a convenience. You learn to do something on Windows remote server. An AWS account, console, EC2. Let's go to instance, launch instance. Going to Windows free tier eligible. That is a free tier eligible. It's a T2 micro. Let's configure instance details. We're not gonna to change anything here. Add storage. We're not gonna change anything here. Let's add a tag. Let's give it a name. This is our packet tracer win server. That is required, okay, because without that you're not going to be able to remote log in into this. Win server, Windows server with packet tracer. The only access that we need really for this is RDP. This is on TCP port 3389, and I recommend that you use my IP so you can restrict the access to this instance. I'm not gonna do that so you don't see my IP address.
Hacker man.
And if you have a network connection that changes the IP address that you receive from your provider, it's going to be a little bit harder to keep my IP here. So you can use a custom or you can keep it in the way it is. So this is an RDP access. For Windows, you only need RDP. Please don't open any more ports if you're not going to use it. If you are going to use SSH or other kind of connections, I really don't recommend. For what we're going to do, RDP is enough. Security group is one layer of security because we're going to use access key, the credentials to really access the server. So this is one of the layers, the first layer within AWS security. Hackerman. Review and launch is going to because I open to the world, letting me know that I'm not really being wise. The recommendation is use my IP as it's going to only permit your IP to access. This is a little review of what you're doing and launch. Now we're going to create a security key pair. If I don't have any key pairs, you have to create a new key pair. Twitch stream, and you have to download that key pair because you're gonna use it later. Here it is. You have to download the private key, blah blah blah. It's launching our Windows instance. It is launching. Here I can see the status of that. It is still pending. You can see that the name that you created as a tag, it is here. It is status checking, the instance state, the availability zone I'm using, what is the instance type, this is the instance ID. It can take a little while, but it's usually pretty quick. Alright, we have it running. Connect a standalone RDP client. If you're on a Windows machine, you're probably gonna have an RDP client already installed. It's really a staple for Windows. If you're using a Linux like me, I use Remina. It is an RDP client. I have a remote desktop. How do we connect? I have here the public DNS already. I copy that here. Username is administrator. Password, remember that key pair that we created? Let's generate the password with that. See, we're using the key name Twitch stream. We're going to get that file, Twitch stream. This is the key. We're going to decrypt that password into something that we can copy and paste. And we are good.
That's the password. We're in.
Okay, let's open an Explorer. netacad.com. Let's log in. Okay, resources, download PacketTracer. Windows 64-bit download. Run. And here we got the good old next finish. Alright. No. Alright. And you got... Okay, we got here PacketTracer, ready to go. I'm done for today, but if I'm about to log off, I will only have access to that file that I just created, that lab that I just did, if the server continues to run. We're still using AWS resource, and we're going to continue to pay for that while we have this running for the EC2 for the storage, and I don't want to be charged on that. I made this mistake once. I forgot to terminate my server. Let's just say that even with the free tier, it only gives you a limit of usage for free. If you extend that usage, you start to pay. I learned that the hard way. Don't do that. Don't forget to terminate your instance. But if you want to keep files, I recommend that we store in an S3 bucket. How do I do that? We're going to install into the server AWS CLI so we can access everything else on the AWS if you want inside this server. There is one little thing called docs.awsamazon.com that can really help you with that on command line interface. Let's install the AWS CLI version 2 on Windows. Let me just get the information that we need. Let's copy this link location. Yeah, save that too and run. Next, 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 install. Okay, finish. And I'm gonna open command prompt or PowerShell to configure the AWS CLI configuration basics. I need access key. Do I have an access key? We can create one. Let's go to identity and access management. I have my user, this is me, and security credentials. And by the way, if you're not using a user, if you're using your root, if I don't have another individual user different from my root, I'm doing this wrong. This is a security breach. Don't use your root account for everything. And security credentials. I have one access key, but let me create another access key so you have the idea, okay? Create access key, download the CSV file. You have to download. If you don't download, you're not going to see this anymore. You cannot recover. Okay, this is the file. We have an access key and a password. Let's get back here. AWS configure. What is my access key ID? This one. Password. What is my region? What is my region? I'm looking here on the Identity Access Management and I'm still on global because it does not require region selection to work. But let's get back to our EC2 to see where we created that instance. We're using CA Central. Here, CA Central 1. CA Central 1. And the output format is JSON. Now let's create S3 bucket. AWS S3. So AWS S3 make bucket MB S3 column slash slash. Let's switch lab. Just made a bucket. Let's see if that bucket exists. S3 buckets on S3 also are global. So here we are, Twitch lab on Canada Central. I just create that. Nice.
Nice.
But our bucket is still empty. Documents. This is where we save our test lab. AWS S3 CP copy test lab S3 columns / Twitch lab. If we list our files in S3 Twitch lab, you see we have our test lab. And if we look at here, I'm going to create AMI image from that. I'm going to take a snapshot of what we've done so far and I'm going to save that image and I'm going to terminate my instance. When I need to launch my instance again, instead of getting that generic image from Windows with nothing that I did so far, I get this one that is already customized for me with the PacketTracer installed, the AWS CLI installed. With the server here selected, I'm going with Actions, Instance, Image. I'm going to create an image. Give it a name. This is my PacketTracer Win Server AMI. When it's done, it's going to appear right here. Still painting. Can take a few minutes. It's taking the snapshot. So PacketTracer, all good. It's pretty simple. GNS3 on the other side is a bit more complicated. Why? We're not going to simply remote connect on the server and do work there. What we want to do is use a GNS3 client locally to access the GNS3 server remotely on our AWS instance, and the iOS and other images going to be running there, but we're going to be coordinating all this and going to use the GNS3 locally. Does it make sense? To do that, we have to establish a connection, a secure connection, and we have to have a GNS3 client on our machine and the GNS3 server on a remote server. We're going to launch another instance. For that, for the GNS3, I'm going to use Ubuntu, also on the free tier. T2 Micro, free tier. Here we can do a little thing that is a good practice. It's like you received a CD or a pen drive or something. It could be already out of date, that system. We're going to give some updates before we start anything. Here on advanced details, we're going to add as a text sudo su apt get updates apt get upgrade -y. What I'm doing here, giving root access to perform this action, then I'm updating my repository on that server. If I give an update, I force the packet system to update this repo list. So with the repo list updated, I can compare if my system is up to date, and then I give an apt-get upgrade to check what is on the repo list and upgrade what needs to be upgraded. If there's something that is already up to date, that's okay, I don't need to change that. But if it's something that is out of date, it's going to be upgraded to a newer version. And the -y is just don't require me to give the okay, the yes to the answer. Do we want to upgrade? Already assume that I give it a yes. When I logging into this server for the first time, it's already up-to-date system. Add storage, not going to change anything here, nothing much. Let's add a tag for the name. This is our GNS3 Ubuntu. Create a security group. Can I use a security group that I already have? No, because you don't have the credentials that I'm going to say you have to do. So let's create a new one. This is going to be the GNS3 server SG for GNS3 server. You already assumed that I'm going to use SSH on port 22 TCP to log in into the server, and it's right.
Nice.
I also recommend that you use my IP here. I'm not going to put it here so you don't see my IP.
Hackerman.
But it's the same scenario. Instead of using RDP to connect, we're going to use SSH because we're not going to install any graphical interface for the Linux. Okay, not gonna need it. Now we need two rules that are going to be important. Second rule is a custom UDP rule. It's UDP port 1194. I also recommend my IP,
Hackerman.
but I'm not going to show you guys. This is the port for the OpenVPN. When you create the tunnel between my client and the server remotely, well, you're gonna use OpenVPN as the tool to create that tunnel, that secure tunnel with a VPN tunnel. That's what I'm doing here. And I'm going to add another rule that is very specific for this case. That is a custom TCP rule on port 8003. Also, I would recommend my IP.
Hackerman.
And this is the port that is going to serve the VPN config. We're going to download the config that's going to be generated by this server to create our tunnel. It's going to get a little more clearer when we get to the configuration on the server itself. What we're doing here is going to open specific ports for what we're going to do. That is, first, download the VPN config from the server that is serving our VPN and the port for the VPN connection itself. I'm going to review this launch. Do we need to create a new key pair? Not really. We can use the same Twitch stream key pair. I already have that downloaded, so I'm going to launch the instance. And wow, it's already running.
Wow.
We have it selected, connect. So we're going to use a standalone SSH. Let's take a look. We have the access keys, we have the Twitch stream, that is our key pair. it requires that I change the mod to 400. What does that mean? It means that I have to change this little thing here. The actual key for this one is 664. Actually, going to change from 664, that is read, write, and execute for owner, group, and all, to 400. That means only read from the owner, nothing, no access for the group, no access for everyone else. We're changing the key. So mod 400. Now, if you do that again, I change it to 400. You have to do this first. Now we're going to connect to this public DNS, and it already gives us what it should be. Wow.
Wow.
Here is our command. SSH using that key pair to each stream, logging on the SSH as user Ubuntu at my EC2 instance, this entire name. Are you sure you want to continue connecting? Yes. Ta-da! The public DNS that we use is this one, and the public IPv4 IP is this one. This is the one that we're connecting to. The private IP is 172.31.17.192. 172.31.17.192. This is not our tunnel IP address. This is not our VPN. This is just the server. And if we try to connect to this IP address, we're not gonna make it. Sudo su. Let's get it to root. We have to install GNS3. Docs gns3.com. Get started. Installation on a remote server. Let's get this. And this can take a few minutes. I'm going to install the GNS3 and OpenVPN. Not just going to install GNS3, it's going to also install OpenVPN so we can pull the VPN information and create a tunnel. In the meantime, the documentation for this script is on the GNS3 official documentation site. We're going to use openvpn.net. It's cross-platform. You can use in Windows, Mac, Mac OS, Linux. It can be used on a bunch of different servers. And we got it done. We finished the installation. Now setup is over. We need to reboot the server as root. So we can put a reboot now. It's going to kick me out. It can take a few minutes. But you see, my connection was refused because it's still not finishing rebooting. The first thing that you can see here, and the first thing he gives me, is download the VPN configuration here. You see that the IP address that it provides me, it's the public IP address 35.183.112.114. 35.183.112.114, port 8003. That's the port that we opened on the security group. That was necessary. If I did not put that on the security group, I would not be able to download this because the VPN configuration is ready only by this path on the port 8003. Let's take this, download it. That's the VPN config. Now I can connect on OpenVPN. I already had it installed, and I'm going to use that file. That is IP. Oops. Operation not permitted. Okay, that's because I'm not as root. OpenVPN IP. Now it's connecting. Initialization sequence completed. GNS3 client. You see that it is configured for local server. Let's cancel that. You see it is using Fedora, that is my Linux. When I install the GNS3, and you're gonna see that when you install the GNS3 on your machine, it's going to install both client, the GUI, and the server on local machine. Can run everything locally, but it gets to a time that your machine cannot take it. It's a lot of VMs running at the same time, and you don't have the hardware, the physical resources to do it. So that's why we're setting up a server. I'm going to edit preference server. Now we're going to disable that, and it opens here for a host and a port. The port is the same, it's 3080. And you might ask me, but we didn't open port 3080 on the security group. Because we don't have to. We're already on our tunnel open for the VPN. But now, what is the host? Is that 35183? No, that is the public IP for the server. That server is not listening on the port 3080 and is not serving GNS3 on the port 3080. Where does it serve it? Let's get back to our server. Let's check for the IP addresses. But I want to know about my tunnel. Haha. What I did here, I used the command IP address. I want to check all the addresses. I could use ifconfig, but that is deprecated. It's good to know both commands. Here I have the tunnel 1194. That is the UDP port for the OpenVPN. This is our tunnel. And the IP address for that is 172.16.253.1. Let's get back to that. IP address, tunnel 1194, IP 172.16.253.1. Put it here on localhost. I don't need any authentication already in the VPN. Let's apply. It's checking for the local server. It's checking. Here, main server. Now we are remote. Wow. See, this is our OpenVPN connection. Let's drop that connection. Boom. The GNS3 server is connection refused. See, error. Because I just closed the VPN. I dropped the tunnel, so he cannot connect anymore to that IP address. That is an internal IP address for that instance. We can install AWS CLI. Is not really required, differently from the Windows machine. There we didn't have connection to outside world to save our labs. Here with GNS3 we're doing this locally. We are running things remotely, but everything else we're doing locally. So I'm just going to show you how to do it just for the sake of it. Remember, CLI on Linux now. We get this. Let's do it. Then we'll unzip it. Now I can use AWS version, AWS configure. Remember this little guy? Region name, CA Central 1, JSON. AWS S3LS, Twitch Lab. Ta-da! I also want to create an image from that. Why? Because we don't want to keep this server running without doing anything on it and paying for that. So we can create an image, same stuff, GNS3 server mi create image. Our packet tracer should be available, and here is the snapshot for that. Here is completed.
Congratulations.
Snapshot. This one is still painting, that's the one we're doing right now, and this is completed, which means we can stop and terminate the other instance, the PacketTracer instance that we do. Instance state stop. It's shutting down.
At last.
That's it, folks. Talk to you in the next one.